pointed out earlier, distillation is usually one of the most efficient ways to separate two different materials. So the book talks a lot about the process of distillation. And here shows several different distillation column configurations. This is for simple distillation, which means there's no azeotropes. It means you can separate your two or more liquids without any problems. The sequencing of the distillation columns is very important when considering cost and just heating costs, because you want to try to reduce your heating and cooling duties. So if you have water as one of your materials, a lot of times it's more efficient to remove the water first to lower your heating duties. And also if you have, say, 3 materials and you have one material that's more corrosive, you may want to try to go ahead and remove that material to improve the life of the column. Now we'll talk a little bit about azeotropic distillation. Oftentimes when distilling liquids mixed with each other, you'll run into an azeotrope. The azeotrope points on this graph are here and here. It means once you get to a certain composition, even if you have an infinite number of stages, you'll never reach past those composition points. So to solve this, you can do one of several things. You can separate close to the azeotrope and then use a different separation method to separate the rest of the material. Or you could add a phase separator in the second column. And you can also change pressures in the second column if the azeotrope is pressure sensitive. Or you can add another component to try to break up the azeotrope. And adding another component gives you a ternary system. And this picture right here is a residue curve. And the definition of a residue curve taken from the book is a plot of the composition of the liquid residue in a single stage batch equilibrium still with time at a given pressure. So how they get these curves is they just take a composition of the liquid, run it as a batch instead of a continuous process. And these arrows and the directions that they move in show how the composition changes as temperature increases. So this starts out with pentane here. And as temperature increases, you see different paths it takes. But all of these, eventually as the temperature increases more, will convert to a heptane. And here are some residue curve maps. There are 3 different types of points that I would like to point out: stable node, unstable node, and saddle point. An unstable node would be right here in this map. All of the arrows are pointing away from this point. So this is going to be your composition at the lowest temperature. As temperature increases, you're always moving away from this point. The saddle point, an example of that is right here. You have, as you increase temperatures, you have a movement toward this composition. But then as temperature increases even more, you have movement away from that composition. It's usually known as an intermediate step. That's where you get your intermediate product. And in the stable node, right here in this diagram, as we saw in the previous slide, all of the arrows, eventually as the temperature reaches the maximum temperature that you want the column to run, will go to this composition. Residue curve maps for ternary systems are also useful in determining if a distillation is actually even possible. For the distillation to be possible, your line from your bottoms product and distillate product have to connect, and they have to intersect one of these heating lines. They have to intersect it. and it has to be the same curve. For example, take this blue line. If this was your bottoms product and distillate product, this is a feasible distillation because it intersects this single curve here and here. Now this, if you wanted to go from a composition, say here to here, that would not be a feasible distillation because it does not intersect in 2 points, either this curve, or this curve, or this curve, or this curve. It only intersects in 1 point here. So this would not be a feasible distillation. You cannot do it for those 3 components. I'd like to let Sarah talk about feed preparation.
For reactor and separator feed preparation, you need to first